Alright, it is time for another tutorial, and this time we're going to talk about on-the-fly beat detection with audio input. So let's jump right in. At first we're going to need a audio file, so I'm just going to grab our beloved song we all know, and so we can hear it, because we will have to hear it to understand it. It is in and I will make it just playing in the background right now. So what is the theory about beat detection? Basically what we want is we want to see or take the time, measure the time between the kicks, which define this time the kicks, but you can also in theory use the snare or anything else. And for this we will need the time between the different kicks, and this basically defines how the BPM works. But how can we in a satisfying way get the take the kicks and then measure the time, because that's what we're doing. So first thing we will have to do is we will have to filter out the actual kicks, and for this we are going to use the at first to see what we are doing, and we will need it later. We are going to use the audio spectrum. So here you can see the different frequencies, and you can already see, okay, there's a lot of stuff going on here, and but there's a lot of other noise which also plays into the analyzing of this whole part, because like as you can see, here's also some very loud element and down here, but basically we want just this what is down here. And to create this, to get it, we are going to use an audio filter, which is here. And as you can already see, there is quite some difference. So because this one right now is a low pass, so this one is filtering out the higher parts. And we can, if we change the roll off, just like the roll off at which they will be taken down. But what we want is we want a very specific range of frequencies. So in this case we are not going to use a low or high pass, but we are actually going to use a band pass. And with a band pass we can define a frequency, and will only take frequencies inside of this range. And to make it easier for us, we are not going to use the logarithmic scale, but we're going to use just a frequency. So here we can define the filter cutoff in hertz in the frequency, and this is set to 10,000 hertz, which is a lot of the stuff really high up. So basically we're working in a range from 20 hertz to something around 20,000 hertz. So to actually get the bass, which really disappear, we want to move somewhere in the range of maybe 20 to 80 hertz. So maybe let's set our filter cutoff here to 40 hertz. And as you can see right now, we have a way more interesting part of our frequency band, which already is, if we turn on our music here again, we can see we only heard like this low noise rumbling. So yeah, we have to actually listen to the music here. So now I can also make it a little bit louder again, and we already have a really nice understanding of, okay, we are really in this low frequencies, but there's still a lot of noise going on. So we can now increase the roll off, the drop off, and we will just put it to 24 hertz. And now you see and hear, if I make it even louder here, you can can see we already have like a really nice spectrum of the bass. But this is still not enough, and now I have to apologize for ear rape, so soon I would just disable the audio output completely. What we can do now is we can increase the filter resonance, and this means that everything really around the 40 Hertz will start to increase in loudness, and will give out way more value than the other one. So let's just really amp this up here, and you can already hear it sounds really shitty. But so now I'm just going to disable the audio device, because now it really doesn't sound nice anymore. And you can see we have now a way better curve going on here. And now we can play around a little bit with the frequency here. So maybe, this is a really, so 50 Hertz is in fact a really nice frequency we have here. And what we're going to do now is we're going to use a math chop to just make this whole thing actually mono. So we're just going to say, okay, combine channels, and we're going to add them together. And now we have this really high peak value, which is absolutely perfect. This is what we actually want. And to get this peak value, we are going to use an analyze chop again. And here we have the we have our peak value going up, just the average. You might even try to use the maximum here. So if we just use a trail chop right here to get a feeling of what it looks like, you can already see, okay, we have this really nice high value. Okay, and actually we will need this trail here again. So because what we want now is we want to actually trigger when we hit a certain value. So in this case, we again use an analyze on this one, and again to get the average. And you can see the average stays pretty consistent right here, which is somewhere around here. And let's increase the average to actually be more like in this 20-something range. So what instead we're going to do is we're going to use the maximum here. We're just going to use a math chop again to set the maximum and divide it by 2. We just multiply it by 0.5. So now to get a understanding, we're just going to use a trail chop again here to see how it looks like, and the price pretty consistent. So now it's 20, and we will just for a short moment merge the two together. And to display them, we can change the way they are displayed, and we're just going to say, okay, all channels in a single graph. And now you can see that this is our trigger line here, and this is the element that triggers our beat detection value. So let's get rid of this, and let's get rid of this trail here. So what do we need? Now we need a trigger chop. Let's put in a null here, so maybe we can play around with it a little bit later. So now let's create a trigger chop here. And the value we want to use to trigger this one is our average here of our analyzed values. And it's always on. This is clear because the trigger threshold currently is set to 0. But we can just use the average over the last 4 seconds and just put it in here as our trigger threshold. And we can already see there's a beat going on. But let's reduce the attack length so it really pushes, and also set the peak length to 0 and sustain level and release length, so we get this really tight trigger. So let's just have a look here, and now we have a really nice line with a lot of consistent values. And as you can see, when we compare it with this one, they are really close together, which is really nice. So how do we get now the timing out of all of this? For this, we're going to use a speed chop, really simple speed chop, which we're going to put in here, and it's going to set an error because it doesn't have a speed. And we're going to give it a constant as an input, and we set this value here to 1. And this way now it will increase the value by 1 every second, with all this nice basically milliseconds here in the get-go, and it will do it indefinitely, which is not what we want. We want to basically store the value we get from this, and we want to otherwise reset our speed chop. Though we can just take our trigger here and just put it into the speed chop here. So now this one gets reset to a value every time we hit the trigger point. Let's organize a little bit, never cross the lines. Awesome. So how do we record this time? That's also pretty simple. We are going again to use, in this case, now we are going to use a record chop, which is here. And you can already see now we get this going up and down, but we can see it's not 100% consistent, which is totally fine in this case. So let's change the mode to add, and let's set as a trigger to do the record. Let's move this one in here. So now it's only active when it only stores a value when this value is set to 1 for 1 frame, which is totally okay. Now also we don't want to have like all of these values. We just want to have a very specific segments and of 4 frames. We want to have 4 frames and want to set this 4 frames and get the average of this 4 frames. So what we do is we set the record output to segment, and then we change the mode of the record segment range to samples, and just say, okay, record segment 0 to 3. But as you can see, it only shows us a 0. And this is because the moment we trigger this whole value here, we also set our speed back to 0, so we record an actual 0. This is really simple to take care of, because we can just delay our speed by 1 frame when it's before it's resetted to record this one. And we're just going to use a delay chop here, and we're just going to say change the mode of delay and max delay to frames, and we're just going to set both 1 to 1. And now we get this quite consistent values right here. I mean, we can also, if we want to get a broader range, so the BPM will stay more consistent. But in this case, we're just going to use the last 4 values, because we can now also build a hand tapper, basically. But what we're going to do now is we're going to create an analyze chop again. And now we're going to set this one to average. And as you can see, surprisingly, the average stays really consistent, even if there are a lot of jumping values around, but the average is always somewhere around 4.7. So yeah, let's create an expression chop here to get the actual BPM. And we're just going to say, okay, me.inputVal, and we're going to multiply it by 60. And then, because we have this 4-beat thingy going on, we're just going to multiply it by 4 also to get the right values. So now we can see we get a lot of non-right values, but we are somewhere around 112, 130. So what happens if we make both of them actual floats? Okay. So now you know when we have a listen to this. Turn this one on. Let's turn the volume down here. And now, for example, we can just use a timer here. We just set the length in seconds of this timer to our milliseconds between the beats. Now if we say restart, now we can maybe use a record shop here. We have our really nice BPM. And to just stop all of this, we can basically just use a whole chop right here, and so now it's always oh no, it's the wrong place, so we have to put it after the analyze. Yup. So we have our whole chop here. And we're just going to use a button right here. We could also use just a parameter. And now if we turn on the button, we set the whole to while on. And now, and when we turn off the button, we will just keep our last value. And when we want to start analyzing, we just activate the button, and then it will continue with the analyzing. So that's it for finding BPM values of some live sound input we could in theory use. And hope you enjoy and have fun.